Have you ever seen an AI look at a picture and wondered how it's not just seeing pixels, but actually understanding what's in it? Well, today, we're going to pull back the curtain on the incredible visual smarts of models like GPT-4 and check out the seriously clever science that makes it all possible. It all kind of starts with a question that sounds like it's straight out of a sci-fi movie, right? How can an AI look at a simple hand-drawn sketch, something you doodle on a napkin, and just turn it into a fully functional website? It sounds like magic, but it's really happening. And here it is, right in front of you. On the left, a quick sketch on a whiteboard. And on the right, a working web page that an AI just made. This is one of those jaw-dropping things GPT-4 can do. But here's the twist. The folks who built it have kept how it works a total secret. And that brings us right to our first section, the GPT-4 mystery. I mean, the big question on everyone's mind is, how on earth does it do that? What's the secret recipe? This secrecy created a really fascinating puzzle for the entire AI research world. Since there was no instruction manual, they had to put on their detective hats and try to reverse engineer the magic just by watching what it could do. And that's exactly what one group of researchers decided to do. And this whole situation led them to a really, really clever hypothesis. They had a strong hunch about where GPT-4's real power was coming from. And honestly, it wasn't what you might think. Their big idea was actually pretty simple, but totally powerful. They thought, hey, maybe the secret to GPT-4's amazing vision isn't some revolutionary new AI eye. What if the real breakthrough was connecting a pretty good visual system to a truly brilliant AI brain? One of those super advanced large language models. So, to see if they were right, they built an experiment, and they called it MiniGPT-4. It was designed for just one thing, to find out if simply building a bridge between a powerful vision model and a powerful language model could actually copy GPT-4's incredible abilities. Okay, so let's get into it. How did they actually build this thing? Because the elegance of how they put it together is really the start of the show here. So the architecture, it's actually surprisingly simple. The best way to think about it is like this. They took two experts that already existed, a world-class photographer, that's the vision model on the left, and a brilliant author, that's the language model on the right. Their big idea was to just hire one expert translator to sit in the middle and help them talk to each other. That translator is that single linear layer you see right there. And here's the craziest, most efficient part of the whole thing. Those two big experts, the vision model and the language model, they were completely frozen. The researchers didn't change them one bit. They just used them right off the shelf, as is. This is the real innovation. The only part they had to teach anything new was that one small translator in the middle. By only training this single, simple layer, they saved a just enormous amount of time, money, and computer power. It's brilliant. But, just building that bridge, that wasn't quite enough. The translator had to learn not just the right words, but how to put them together into fluent, natural conversation. And that took a special two-part training process. So first up, they taught it vocabulary. It was like making it memorize a dictionary. The model went through about 5 million image and caption pairs just to learn the basics. This is a dog, that's a tree. But then came the really critical second step, teaching it how to actually converse. And for this, they used a much, much smaller hand-picked set of just 3,500 super detailed descriptions to teach it how to talk about what it sees in a way that sounds natural to us. And this difference is everything. I mean, after that first stage of training, the model's language was just awkward. It was repetitive, it knew the facts, but it couldn't tell a good story. It was that second, much shorter fine-tuning stage that unlocked everything, turning it into a model that could have natural, reliable, and genuinely useful conversations. So after all that clever engineering, we get to the payoff. What could this new AI actually do? Well, as it turns out, the results were even better than the researchers were hoping for. So let's take this picture of a city street. We'll compare it to the previous top model, Blip 2. Blip 2 gives a pretty basic description. Yeah, it's correct, but it's simple. MiniGPT-4, though, it sees the clock tower, the shops, the restaurants, the parked motorcycles. The jump in detail and just awareness of the whole scene is absolutely massive. Now, this next one, this is where it goes from just describing things to actually understanding them. When you show this meme to the older model, it just tells you what it sees. But MiniGPT-4, it gets the joke. It actually understands that shared human feeling of having a case of the Mondays and can explain why the meme is funny. That's a huge leap. And this final one, this really shows the jump from describing to creating. Give it a picture of some cooked lobster, and the old model spits out a single, generic cooking instruction. But MiniGPT-4, it generates a full, multi-step recipe with a whole list of ingredients. It's not just seeing anymore, it's reasoning and creating from scratch. So, what do all these incredible results really tell us? Let's dig into the data and figure out what the real secret sauce is behind all this success. Okay, here's the headline number you need to know. When they tested it on all kinds of advanced creative stuff like writing poems, making up ads, or generating recipes, MiniGPT-4 got it right 65% of the time. Now, this table really puts that number into perspective. Out of 100 of these advanced tasks, the old model, Blip 2, only succeeded 5 times. MiniGPT-4, it succeeded 65 times. And just look at poem composition. Blip 2 failed every single time. MiniGPT-4 nailed 20 out of 25 tries. The difference is just staggering. So what this all boils down to are 3 key things. First, the researchers' big idea was right. The real magic happens when you connect a vision system to a really powerful language model. Second, you can do it super efficiently by just training one tiny little connecting layer. And third, that final quick fine-tuning session, it is absolutely critical for turning the AI into a communicator that sounds natural and that you can actually rely on. And that leaves us with one last really fascinating question to think about. See, the researchers called their model MiniGPT-4 for a reason. It was an efficient, smaller experiment. So if this is what a mini version can pull off, what happens when this incredibly powerful and efficient technique gets scaled all the way up? The possibilities? Well, they're pretty extraordinary.